So, hello again. This is my third live stream, and this time we're gonna do the PageRank in C++. Yeah, I've decided to. Last time I thought we're gonna do a bunch of stuff and pretty advanced, but yeah, I think we're gonna take a step back and implement first the basic algorithm in C++, and we'll actually see how that is good compared to Python somehow. And yeah, hopefully that's gonna be interesting. So as always, please post any questions in the chat, and subscribe to the channel and if this content is relevant and interesting. So yeah, basically let's get started. I think I'll try to be I'll try to keep under 2 hours, but we'll see. I've actually no idea as usual. So let me get started. As always, we're gonna initialize the setup first, and then continue. But yeah, maybe prior to getting started, Chrome. Let's go on the Memgraph web page. Just quickly, because recently, so yesterday we released Memgraph 1.3, which has a couple of interesting features. So here is a release blog post. Most notably, we added the replication, which is an enterprise feature, and a couple of smaller features. The most interesting one is probably logging, because granular logging that enables debugging and in general figuring out what is going on in an easier way. So yeah, you can read more here, but I'll just download Memgraph Docker image, even though I've tested this, so I already have downloaded it, but just to showcase how to load the image again. So while this is downloading, I'll quickly swap here. So basically, to load an image, docker load has to be executed, and this is still not downloaded. While this is getting downloaded, I'll try to set up usual stuff. So actually not here. Let's do this here. So, and yeah, one more. So today is this date. Okay. Okay. We probably have downloaded. Yep. So docker load and Memgraph. So this is the latest version of Memgraph. It's loaded now, and you can see all Memgraph images by executing docker images. And here we have 1.3, and it's the latest one. So yeah, let's close this. Go back here. So prior to actually doing some stuff, I'll do a little bit of setup. I'll publish all my setup for this machine on my GitHub profile, but it takes some some time to get everything ready. So that's gonna come soon. Maybe next Saturday I'm gonna showcase that a bit. But for now, I'll just do manual stuff here. And yeah, that's it. So let's start the MOOC session. Okay, that's one thing. And what else? Yeah, let's initialize the whole thing. So I'm usually using Vim, and for the C++ development, I have the language server CCLS, and also the coc.nvim plugin, and I'll do a little bit of setup around this here. I won't go into rabbit hole about all that. I might record additional video about that, about all of that. For now, I'll just do something quick here. So let me do that. Let's say, and yeah, the first step probably is to prior to setting everything, there is also one interesting repository that I forgot to mention. Let's quickly do that as well. So in addition to 1.3 release, there is also another public open source repository called Memgraph MAGE. MAGE, and here the plan is to put all the query modules in various programming languages. It's super basic at this point. We just initialized the whole thing. But today I'll just use this as a. We already added some more scalable PageRank code, but that's the next step. So I'll just reuse some of the parts from that code today to build the basic version. So let me quickly clone this. Actually, I'm gonna start another MOOC session. So git clone here. Okay, and let's go. Okay, great. And yeah, we need C++ part for this time. Okay. Okay. Great. So I'll just reuse some parts from here, not to type everything. I think that's easier and faster. So we need a CMake configuration. So let me copy paste that, and let's go back here. Great, and we need. So I won't explain all these CMake and build details in all the details this time. That's also for another video, but we'll try to cover basic stuff and maybe record a dedicated video about that. So basically, we just need a CMake lists file at the top of the at the top folder, and to start the configuration. And yeah, so actually have to. Let's do this. Okay, now we good. We don't need this. Version is okay. Project is going to be called just simple PageRank, and sorry, I swapped caps lock and escape finally on the keyboard, and now I'm stuck a bit, but that's all fine. So let's set up this. So by exporting compile commands, basically that's gonna generate a compile commands file in the build directory, and that will help that will help to the language server to generate all commands so that we can have analysis of the code inside Vim. So that is useful. Let's keep C++ standard to 17 required on. We don't need that. So yeah, I won't cover good practices that much this time, even though I'll try to do some basic stuff. But yeah, my main goal here is to do something end-to-end first, and then we're gonna do good practices and all these things. So let's keep here. So under compiler flags here, we're gonna just leave warning all. That doesn't actually mean all the warning flags. So this is actually like a minority of warning flags. We need to add more to enable all of them, but let's leave it as is for now. We don't need the rel with deb info. That's maybe a bit too specific now. For the release flags, yeah, O2 and debug, that's fine. This setup here is just saying that when we build a dynamic library, a query module, it won't have prefix lib. Usually it has, by default, it has prefix lib on Linux. So this will just that will just create a file name which will be defined here. So let me also remove this. So yeah, this is required. We don't need this. We need this. Okay, and we don't need this. Okay, and target library. Here initially I'll just do the example first, and then I'll start doing PageRank. So I'll call this library an example. Okay, sorry. And example CPP. Okay. This is again. So here we need example again. Private. Yeah, that's gonna include directory, and in the include directory we're gonna put header file of the query modules. So let's leave it as is for now. So we good here. We have this here, which is great. I'm gonna just create another file which is called example CPP, and here just basic stuff first. So just static void dummy, like a dummy function that will be compiled, nothing major. So I think we actually are ready to compile stuff here. Let's do this. Usually with CMake, a build directory has to be created. So let's go here and call cmake ... That's gonna initialize the make file. So on Linux, CMake will generate a make file, and that make configuration will be used for the compilation. If we'll list here, we have make file in the directory, and also we have compile commands that will be useful a bit later. That's fine. And if we run just make, that will just compile the whole thing. And as you can see, we have example.so in the example.so was generated. I think it should be here. Yep, it's here. But to actually see what is going on during the compilation time, we can also put we can also run make and then verbose equals 1. So that will generate verbose output of the during the compile. But since we actually compiled the example, we have to remove all this and then run the whole process again. So make verbose 1. So yeah, we have here more verbose output, and this is the compile command, and it has a bunch of stuff. So C++ compiler, our GCC is used to compile. I'm actually not sure what's the purpose of this, but fine. And then this is just adding a define symbol or something, nothing really relevant. But we have the include directory here. That we define that in the CMake file, and then the warnings, and then fpic. That's a position independent code. So this is a flag added to create these dynamic libraries. So each query module or each query module in the repository will actually be the dynamic library. So that flag has to be here, and this is the C++ standard, and then output file, object file that's generated, and the source file. So we're good on that side. Okay, let me just do one more thing. So if I go here, and so in order to do something with in order to build a procedure for Memgraph or a query module for Memgraph, we need the header file. So I'm gonna do a quick dirty trick here. I'll just take that file from the Docker instance that I'll start right now. So Memgraph. So docker run -rm to delete the instance, the container right after, and 687 Memgraph, and that's gonna start Memgraph instance. Yep. So we have 1.3 version, which is fine. So in the latest version, we slightly changed the logging. The logging is improved a lot, but it's a bit different. So in order to see all the logs here, I'll just add additional flag, even though we don't need that yet, but in any case, I'll add the flag also log to std error. So yeah, that will print all the logs here, which is nice to have. That's very good for now. But yeah, we needed the header file to build the actual query module. So let me just open another terminal here. Yeah, and this time my picture-in-picture will overlap a bit, but I'll place myself to another corner. That's the that's the best solution I have right now. So yeah, I've a little bit off topic. So I've got a bunch of feedback from the Memgraph team and people from Memgraph about the live stream. I haven't managed to implement all the improvements yet, but yeah, feel free to suggest anything, and I'll try to implement these live streams. We'll have a bunch of live streams, so eventually I'll implement a bunch of stuff. Anyways, let's just connect to the Docker by executing docker exec -it docker name and bash. So you can find that file here. So user include memgraph MG procedure. I mean, I'm just hacking a bit now just to showcase all that. But that file will be also available in the MAGE repository. If you take, it's already there. So if you take a look under include, there is the file. I'll just do a bit slightly slightly harder way of finding it, but still it's applicable. So here we also have that file, and in order to copy that, we'll just do we are here. We'll go a step back and create. Since we said the folder will be called include, mkdir include. That's correct. And so you can copy files from Docker by executing docker cp and then the container name and then usr include mg.h, and we want to copy that file exactly here. So if we list this, it's fine, it's here. I'll go a step back here. I can place myself back here, which is fine. And if I reload here, I have here include directory with mg procedure and CMake lists file and all the other files. So that's great. And now let's do here, let's include here mg procedure.h, and at this point this is gonna complain, and that's actually the language server unable to find that file, and that can be fixed by adding additional configuration for the language server. I'll quickly do that, and I think that's the last configuration part today. So let me go back. CCLS. Wait. Let's take a look here, and then getting started, and then where is that? So do I have? No. Let's configuration. No. Where is that? Wait. Yeah, here. So CCLS far. So we have to say to him that that we want also the header files to be included, and I'll make a nice config for that later. But for now, I'm gonna just copy this part here. That's the simplest example, and we are good with that example for now. So here I will create touch CCLS. Go back here. We have that file. Let's copy paste here, and that's basically it. So we don't need this, and I think we also don't need this, but we'll check that. So yeah, that's correct. And if I just close this, just to reload everything, I think, yeah, and this time is fine. So it's CCLS managed to find the include directory, and also it says unused function dummy, which is fine because that function is not used for real. That's amazing. So at this point, I think we can start with basic example. So let's go back here, and we have that example actually here shipped with Memgraph. So user lib Memgraph, and then query modules, and then get example. So that's the C example. We're gonna just change that example a bit to be okay with to work on with C++ as well. So we actually don't need this part, we need just this. So copy that and go back here, and okay, we good on that side. We don't need the dummy function anymore. Okay, and so we have the procedure here. So this is very similar to Python code that I've explained in the last video, but yeah, I'll try to go step by step and fix stuff in order to compile. But let me first comment on this side. So the procedure, each procedure accepts a couple of arguments. So first is MGP list. That's a list of arguments that, if you remember, when we call a procedure by calling call and then procedure name, there are arguments as well, and these arguments are passed here as a list. Then the procedure also gets the whole graph, a pointer to the whole graph, and also to the struct that holds the final result, and the memory. This is for the purpose of memory allocations, because each query module, each procedure when run has a limited memory space, so it can't like take entire memory and then crash the whole Memgraph. So these are the arguments, and then let's now skip that part with the implementation. We also do here registration of that procedure. So so here we add a read procedure, and like basically it's called, I think it's going to be called procedure, and name is procedure. Let's actually go here. So this is a function that adds. So one query module can have a couple of like more than one procedures, and then each procedure can be added. And as you can see now, as you can see here, name like module is that module is name, and callback is the procedure, and the module, I think that's the pointer to the module that is passed here. Let me go back. Okay. Okay, and then once we have registered procedure, we also add these arguments. So let's go here. So each procedure will, by doing this, you can specify like the required arguments, and then you have kind of type safety. So you can define like when you call the procedure, the engine can know what are how many of required arguments are there, and then throw an error if the call is not right and stuff like that. So So let's go back, and then we just say here that we have required argument, one required argument and one, I think, optional argument. You can also add optional arguments, and then you also have to destroy that in case of something is in case something fails, and that's how C works. So that's fine here. Yeah, you need to shut down if you allocate some resources. If you acquire some resources in MGP init module. So that's about it. Let's go back a bit here. So here we have some errors, and they say cannot jump from this go to statement to its label. I think that's a problem because we are doing C++ here instead of C. So I'll just remove this. So this goes under memory error. So I'll just copy paste here these examples here for now. So copy here and then I can't do that. Copy that and then go I'll just replace this go to statement with the actual error. I also have the Clang format setup, so I'm gonna use that to format the code automatically. So don't be worried about that at this point. It's all good. So also we have to actually free memory here. So I'll replace this with this, and also this the line that we replaced last time. Okay. So this and this. I'll make a additional improvement, but let's do like this for now. Error free list. So again the same. So copy that, place it, put it here. That's fine. Error free list again the same. So let's just copy that entire block of code and just put it here. Why that? Great. So that and error memory, we need just this one. Okay. That one here. That's fine. What else here? It's fine. Error. Memory error. That's the same. So just copy here. Copy. Copy here. That's also fine. And memory error. So just need this part here. So this is a bit boring because that's C, so we have to handle errors properly. I hope I didn't make any mistakes, but at this point we should be able to compile this module. We have two return statements, so yeah. Okay. Okay. let's go back to the build again, cmake, that's fine, and then make. Okay, and now we have the SO file which is ready to be loaded, and at this stage I'm gonna just try to load that entire build directory from Memgraph and try to run it. So let's go back to Memgraph. We don't need this anymore, and here yeah, now we have to mount that directory. So I'll just try to do that simply by mounting the volume. So home mg workspace code memgraph, and then code, so live stream 31, and then build, and that should be fine. And then since query modules is defined, lib memgraph query modules, hopefully that's gonna fly. Yep. So okay, we have these additional files that have to be ignored, but like these make files and stuff like that, but Memgraph is just ignoring that. But we don't have mgpy init module symbol for some reason. Why is that the case? Okay. Why we don't have that? Maybe I missed something in the config. Add library shared, private include, I think that's fine. Okay. I might. Okay. Aha. I think I know what's the problem, because we didn't export that. Yeah. Let's go back here. That's C++ stuff here. We actually need a bit more advanced stuff. So I forgot one thing. So we have here another example. I will talk about that algorithm as well. But since we are in C++, we need to do this. So we need to make this part here, and then that's gonna be a C function. So instead of doing this, if we compile this, if that would be a C compiler, then it would work. But since it's not, we need to sorry, we need external C int. We need to just add external C. I think that's fine, and also here. Okay, let me compile the whole thing again. Good, and load. I can just go in. I think I can just do the reloading through Memgraph Lab. So if I go back to Memgraph Lab, we go here, and we do, as usual, call mg.procedures yield star. Great. Load all. So we just have to call load all. Did we actually do something? Maybe. We reloaded something, but let me check the procedures. Oh yeah, why? For some reason it didn't print that it successfully loaded procedure, but fine. So let's go back a bit and check what the procedure is actually doing. So it says just simple stuff, copying of the arguments, and then so make a list of to copy arguments, and then just copy arguments in args copy, and then that args copy is used somewhere. Args copy. Args value. Args value. So like arguments are just copied and then returned. So I should just be able to call example.procedure. I need one required argument, which is, for example, test yield. Yeah, and then I have a list and a result. So args is we put args we put copy in the column args, and then we also put hello world as a result in the record, and then that is returned. So we have test and null. I think null is the optional argument. So because we didn't provide the optional argument. But anyway, so we now have working version of the query module, and now we can finally jump to the whole PageRank stuff. Okay. I'll again try to do the work from here. So I'll just rename this into PageRank. Actually, no. Let's leave as is. Let's leave it as is. I'll just copy PageRank. Okay, we have another procedure of the same other file of the same name, and let's go back to the CMake list file and add one more library. So I'll just do here. So instead of example, I'll put PageRank, and the file is called PageRank, and we also need to include MG procedure PageRank. Okay, and if we compile this, boom, we have example and PageRank both ready. What's gonna happen? So since we have actually two files, but the files are modules are registered under the same name. So I'm gonna try to run that just quickly to see what's gonna happen with Memgraph. I actually never test this, so let's try it. Let's try to break it. History and load all. Boom. Seems like it managed to survive. I think it probably just override the whole thing, which is fine. One of possible solutions. If we run procedures, actually no, we have two. We have PageRank procedure. Wow, great. Sorry, I had a different idea in mind, but yeah, we have since we since the module is called differently, it actually has a PageRank procedure and example procedure, which are essentially the same. Okay, that's great. Let's go back here. Okay, and again, I'll try to do super simple and dirty implementation of a PageRank. Everything is going to be placed into the procedure function. So I'll just change here. So what do we need? We need, for each node, we need node ID. We have to return node ID and then the rank. So let's do that instead of procedure. We're gonna just call this like PageRank.run, and that's it. So it can stay. The function name can stay. Can still be the procedure. We need argument. What about the arguments? Yeah, we're gonna do the whole graph, so we actually don't need the arguments. Because we don't, we're gonna do we're gonna run PageRank on the entire graph, and since that's it, that's that. I think we can just remove all that from here. So we don't need this null value. We don't have that, and so result, the first will be the first return value will be node ID, and MGP type is I think why the MGP, why I don't have the completion here. MGP something. Okay, not sure why I don't have the completion. Okay, what is happening here? I again don't have. Somehow I managed to. My configuration got broken. Why? Not sure, but anyway, let's try to restart it. Yeah, somehow my language server died. This is an example. So node ID, okay. Okay, MGP string. So what do we need? We need node ID. MGP, but that's integer. So MGP type int. So MGP type int. That's node ID and rank. Rank is not a list. Rank is MGP type float. So rank in the PageRank is of type float, and if that's not okay, then return 1. That's good. We don't need this. We don't need this. If anything is fine, we return the actual. We return 0. That's I think fine, and let's just delete all that for now. I'll just do basic. I'll just return basic results. We don't need this. Let's delete all that. We also need documentation for now. value hello world. Okay. Make, let's say make, I'll just try to return some hard-coded values. Make int and let's say 1. Why is that questionable? It's up. Don't need all that. MGP value. Okay. Okay, hello world value, not value. I'll rename that to int value. Int value, la la la, that's fine. And okay, if int value is, since we are in C++, we can null pointer here. That should work here. If that's unsuccessful, then fine. Result inserted. So record. I've deleted the actual record. So, and the result as well. I need the record. So I need the record here. No, I need the record here, and I have to check if that's okay. Let me put myself here again. Okay. So we have record. Let me. Now we have the record, and we have to insert the integer value here. Int value, okay. And that's inserted. Once that's inserted, we can destroy it by running okay. We now have the integer value. Let's just for now ignore this to be able to. Okay. Okay. Load all. Okay, we reloaded, and yeah. So PageRank.run blah yield. Boom. Something triggered. Let's go back to the code. MGP memory int value. So let's be a bit more descriptive here. So unable to make integer and unable to insert integer. Is it visible? Yeah, in integer. Okay. Load all. Yeah, we really need a history feature here because it's a bit too hard to navigate here. So load all example. it's not saved. PageRank.run yield star. Unable to insert. Why not? So the second one is broken. Maybe I deleted hello world value. No, that should be fine. Record result. MGP result new record. Okay. Okay, here we need also if make a new record. Okay. Okay. Maybe that's the problem. So we unable to create a new record. Result is there. I really don't see the problem. Let's try to compile, and maybe that's insertion is actually wrong. Yeah, on these live streams, it's sometimes it's very strange to detect problems. PageRank. Yeah, no, this is okay. So the last one is failing. So a record. I have record, which is fine, and I have value, which is fine. Aha. Maybe because node ID. Copy pasta problem. Okay. If I reload. Call. Yeah. Okay. Yeah. It's very hard to see the problems sometimes. Obvious problems. Okay. Okay. But yeah. Let's try to do some actual real code. It's already 1 hour past, and I'm still at the beginning. So okay, if you have some questions or some suggestions, please do. I'll try to take some water first and then continue. Okay. So let's finally get to the PageRank part. So let's go back to the image that I had last time. So downloads, we have this here. How to I forgot how to enable the GNOME. Okay. Okay. So in order to calculate PageRank, we need a couple of things. So PageRank of a page A is some constants, and then this part. And this part is interesting because it has PageRank of T1, and T1 is a page that is linking to A. So PageRank of that particular site divided by the number of outgoing edges of that T1. And I think this one is also included. So so in this case it's so this first part here is so PageRank of T1 divided by 5. So PR from T. And so in order to calculate that, we need two data structures for a given graph. So we need a list of incoming edges for page A and the number of outgoing edges for each page. And initially, I think initial values should be equal values. So each PageRank of each site should be 1 or something, or like, I don't know, number of nodes divided. So 1 divided by the number of nodes. I think anything is applicable. It's just like eventually the result is going to be equivalent. So I'll try first to transform our graph from Memgraph into these two data structures, and then so I'll do basic stuff. So I'll copy the entire graph into these two data structures, and then we'll implement the actual algorithm. So let me close this and go back to the code. So okay, in order to do so, one of the suggestions was that I should have some templates. So that's why I'm copy pasting a bunch of stuff. So not to reinvent and to try to remember all these things. So I'll go back to the MAGE repository, and we are adding actually a scalable version of PageRank as a query module, but it's not polished yet. It still has some work, and I'll just quickly try to find. So yeah, since I have that in the code, I can also do this here. So I don't have ignore. Okay. What's the PageRank module? Okay. PageRank module. So I'll just use this code, some of the components, just to accelerate a bit the whole thing. So PageRank. PageRank module. Oh, okay. So we need. I also don't have the setup here. So I'll try to do the good old way. Vertex ID mapping, vertex ID MG utils. So that's located under utils, MG utils, vertex ID. So I need no. I need something else. I need vertex ID mapping. So yeah. Okay, so this part here is gonna do the actual iteration through all vertices and then find all the IDs, but that's kinda okay. We need actual edges, so in both cases we need edges. So we need this part to iterate through all vertices. Actually, let's copy all that. It has some good parts. Okay. I'll leave that for now. Okay. Somehow I've managed not to copy. Should be copied now. Okay. So we have a graph. We have an iterator through all vertices. So in this function here, why this is not indexed yet? But anyway, so that's gonna give an iterator to the vertex, and if that fails, we exit. But yeah, we should do. Yeah, I think I also need to do that immediately because it's gonna become too messy with the allocations. So yeah, let's do that. So I'll add another utility here just to clean clean all these things. So this is called OnScopeExit. That's a C++ utility function that basically does the cleanup on the scope exit. So I'm gonna use that to simplify the cleanup. Let me just pull that out from somewhere, pull that in from somewhere. So include, and I'll copy that from again MAGE. OnScopeExit and put it here. Okay, I have that here. Okay, let's leave it as is. So what this does, this is an object that when this is basically C++ RAI, let's say pattern, and whenever that object is destroyed, the lambda function defined through constructor is called. And basically the idea here is to define that object in the procedure, and then at the end of the procedure this function is going to be called and the memory will be deleted. So instead of I'll just close this to move that here and put myself up again. So instead of doing this crazy stuff after each call, I'll just call that function, that I'll just initialize the object. So I'll include on scope exit HPP, and now that should be available. Great. And yeah, vertices iterator. Why is that null pointer? If that's, we actually don't return anything, so because that was another function, so we return from here, which is fine. And then this vertices deleter, we need to have an object here because that object has to be deleted. It's not, we can't avoid naming the actual object that will be created. And we capture vertices iterator, and then we just check if that's different than null pointer, and if it's not a null pointer, then we call delete, and that's gonna be called after the whole scope here, after the whole code here. So we don't need this, and we have now here iterator through all vertices. Why is this? So when we call get, I'll just go through all of this functions a bit and explain. So we got the current vertex pointer by the iterator, and this value must be not used. Okay, so let's go. No. So we just call the next one in the for loop. So we are iterating through all these vertices, and we fetch here vertex ID. Vertex ID on the other side is vertex ID, which is int 64. Why is that code int 32? Okay, okay, that's interesting. Okay, as integer, I mean, we can do auto here. Vertex ID. Okay, and I'll be a bit more consistent, so I'll do ID here, vertex ID. So we have now vertex ID, which is fine, but we also need edges for each vertex. So we need to build an adjacency list that counts all incoming edges. So that takes all we need a list of outcoming edges and the count of them. That's fine. And we also need adjacency list of all incoming vertex IDs. So let's take that somehow. Okay, let me check. So how to do that? Let's go through all vertices. And then if we have a vertex, what do we have from the functions here? Make vertex, la la la. Get vertex, get path, labels. Okay, so here we have all in edges. Yeah, that's what we need. So for a given vertex, give me all inbound edges of a given vertex, which is great. And then we're gonna somehow collect. So we need to know all these node IDs on the other side. So okay, let me take this. La, 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 la. So for a given vertex, we need. Oh no, that's wrong. Sorry. Vertex ID, which is fine, but also we need. What do we have here? So vertex. I think we need graph and memory. But we also need the vertex. Sorry. So vertex, memory, and what else? Vertex and memory. Okay, sorry. Yeah. Sorry. Okay. So we need vertex, memory. Okay. Now we have the actual iterator through all the edges. Pointer in edges iterator. Okay, great. So now we have that, but once we have that, what do we do with that? This is wrong. Iter in edges. Yeah, this is a bug in the navigation. Okay, we have iterator, and that iterator I have to get all the edges back. Iterator, all the edges. iterator get. So I'll try to do that without the error handling first, and then I will add error handling. So no, edges. Edge, okay. Once I have the edge, what do I do then? I need to fetch, so I need basically an ID of a vertex somehow from the edge. So once I have the edge, how to get edge, get edge ID. So I have get from, yeah, get from and get to, and yeah, from is, if I take from, that's gonna be the node on the other side, and that's what I need. So okay, now I have that, and I have auto. So how to say that? I have no idea. In, let's say in vertex MGP edge get from. Okay, now I have in edge, and I have ID. I need ID of that edge. I think these are all pointers. So auto in vertex ID equals to MGP vertex get ID in vertex. Great. Okay. But I also have to iterate through all of that. Can I somehow figure out the size of that graph? Node number, no. Maybe to 11. Does it work here? No. Nope. How to know the graph size up front? Allocate, destroy, no, append. Extend equal, nope. No. That's a bit shame if I cannot know the size of a graph up front. How is that done in the MAGE code? Just a second. It just does the mapping. I could initialize. I could just go through all the vertices and then figure out the size of a vector, and then figure out the size and then use that as a size. Let's do that. So let's just iterate through all vertices first, and then collect all the the number of vertices and all the IDs. Do I need IDs for something? I think no. If I have IDs. Let's do that first, and then it's gonna be easier to figure out the rest. Vertices count plus plus. Let's just count that for now. And yeah, let's do that properly, and then we extend. So don't need this for now. That's also useless. Okay, we have the vertices count, and then let's actually just count this first. Okay, we have the vertices and la 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 la. That's fine. Integer value. Let's move all these at the end. So integer value, make int vertices. Vertices count int value. If that's not unable to make that a record, make new record result inserted. Then let's not do this again. This is now count, and this is vertices count value. And vertices count value, we can now do the same here with this. So instead of destroying that after, let's vertices count value okay, this is not required. If not inserted, unable to insert, and we good. Okay, great. Let's go here, delete this. Now we should just have the count of vertices in the graph, which is also fine. So let's go back and compile this. This is again taking much longer than I expected. So okay. Let's go back to the lab. Let's reload. That's fine. Let's run PageRank. Nothing. Ah. Where do I have node ID? Vertices iterator, that's fine. Count. Let's create just two simple nodes. Now we have 4 of them. Okay. If I run PageRank now, does not yield a record with node ID field. What the fuck? Something is left from before. What? Insert. It seems that we haven't reloaded anything, but why? Run count. Okay, let me just kill Memgraph. Am I in the right folder? Yes. Okay. Okay. Procedures. List all the procedures. Count integer. Yeah, we have the count, not the. And if we run the procedure, yeah, this is some kind of a bug as well, because I'm not sure why the module was not reloaded. Okay, anyway, let's try the initial idea. If we do this and if we run PageRank again, we have now 2. Okay, and we have the actual count, which is okay. Okay, great. Yeah, I'll just do simple stuff. So I'll try to calculate all these vertices, and then So basically I need two vectors, one for ranks, one for outcoming edges for each node, and then but I need a mapping as well. That's a bit strange. That's also a bit how to solve that in the best possible way. So the problem is that I have vertex IDs, which are some IDs in the database. But yeah, I would like to allocate a vector and just put values consecutively in memory. But that's a problem because I need additional mapping to ensure the right IDs at the end, so that we return the right IDs for each vector. But yeah, I need that, so I will just have another vector with the mapping, so that I know each ID of a vertex. So okay, now, but yeah, I can use the same. Yeah, my idea from the beginning was actually okay. So I can use where is the vertices count. I don't need the count. I just need std vector of int 64. So mapping. So that will have the mapping. So on the node, on the position 0, we're gonna store the actual ID of a node, and since we have this, we're gonna just push back. So mapping, push back what? The ID. So we're gonna just push back the ID, and that's fine. So MGP vertex get ID of vertex. Why is that wrong? Why vector doesn't have okay. And this we just need size. So for the actual number of vertices, we just need to get size back. This is great because here we can define another two vectors. So std vector of what? So we need these incoming edges, and so incoming. So based on incoming edges, we're gonna have incoming nodes, and we need to store adjacency list of these nodes. So actually we need another std vector here, which let's just try to run this really quick to ensure this is actually working. Of course, what's the problem? Cannot convert ID to unsigned int. I need ID, vertex get ID, and that's because that's a struct. As int, okay. As int, okay. Great. Let's now try to reload. Hopefully this is gonna fly. Even though I'm not sure now, does it really working? It's the same. Yeah, hopefully it's working. So okay, we have the mapping one, and so okay, we need another vector. Std vector of, again, int 64t. So in adjacency, let's actually set spell. Yeah, okay. In adjacency, so that's for incoming adjacent list, adjacent vertices. And what else we need? To the vector of 64t. So out count. So that will tell us we're gonna count all these outcoming edges for each vertex. Okay, that's good. But we also need to store, because for a given vertex ID, we need also the position in the map on the other side. So mapping here is a bit strange. Okay, let's just count out count. I think that's a bit easier. So count value since we are iterating through all, we can also put this here, and we can just count all the outcoming nodes, but do we have out? So I again have just the iterator. Can I get that from the nope. Yeah, I have to iterate through all the edges, through outcoming edges, and then That's what I wanted to do here, but just in the other way. So in edges, okay. So vertex in, but instead of in, we're gonna do out. Iterator. So basically I just have to iterate through all of them, and that's it. Hopefully, yeah, time really goes quickly. So yeah, I think I'm gonna cut this for now. So I'll try to count these things that are important, and we're good for today. But yeah, let me actually do that. So we have that iterator, and while we have next MGP vertices, edges iterator next from out edges iterator. While we have that next, we should count. So for that edge, so int while we have next, we should do outage counter plus plus. Okay, and now we know how many outcoming edges that node has, and that's amazing. And we should just store out count, place back out edges counter. So is this correct? If we next, so we're gonna do 1, 2, 3, 4, and then the last one that might give like wrong result. So but yeah, let's test it. I'll avoid returning stuff because it's a bit verbose. I'll try to print for now. Should be easier. Actually, I should set up the debugging. Let me try this, and then I'll also try to set the debugger to know exactly. But okay, out count and place. So we can do printing here as usual. So out edges counter. Good. Let me reload. Okay. Now we have two. That's okay, but in the logs, boom, haha, we have some memory leak, haha, which is interesting. Why? Because why this didn't print anything? Leak is probably because I didn't clean up something down the down here. But I didn't clean the iterator. Edges iterator. I should do the same as here. Okay, out edges iterator deleter. Okay. Good. Let's see now if we have the memory leak. Load. Run PageRank. And the result is fine. Now we don't have. Yeah, that was good. Yeah, as you can see, it also the query modules infrastructure is also smart, so it prints the memory leak, so that's convenient. That's good to know. So amazing. But why I don't have? Why this did not print? 3. Aha. No, but it should be printed since this has a 0. Maybe it is, but I just don't see because Okay, but let's anyways, let's try to return this as outgoing edges, outgoing number, just to try all that, just to return all that together. How to do that? We have to add all these things. Okay, let's print the mapping and the out count for now. So we'll do that by creating the value, so we can do simple stuff here. So for let's say ID, if we go through all the mappings and then we have to create the value, but it's not count anymore, it's ID. It's ID value, and we just ID memory. Okay, that's fine. We create the integer. We do ID value if that's no pointer. That's fine. Record. That's fine. We create a record. Unable to make vertex ID, which is fine. We do this vertex count deleter. I mean, I'll need that code either way, so it's fine. Vertex count deleter. That's ID value deleter, and ID value ID value. This is very boilerplate, so we'll create some functions to deal with that at some point. This is also fine. A result inserted a record under, so ID. Let's say ID, and we should add ID value. Unable to insert ID. Okay, let's delete this. We don't need this for now, and that's for loop, and let's close it. Yes. Something, I'm missing something. That's fine. That's fine. This is good. This is good. This is good. Really? This is nuts. Okay, but yeah, okay, anyway. Let's try to reload. Load all. And then rerun. PageRank run. This is again the same issue. So it says that count. It says the count and it's loaded again. So it should be loaded and it's not for some reason. But why not? If I delete all that and compile it again. And if I reload now. Okay, if I run now, yeah, I don't have count anymore. And if I reload, yeah. Okay. I have the IDs, but yeah, there is some bug. Plus, the client format is crazy here. Why? Why it does this? No idea. Okay, anyway, let's try to actually count something. So let's create this, and then let's create outgoing edge. I have two edges. If I now run the PageRank, I have IDs, but I have to return counts as well. So I will also put out count here. So I'm gonna also this doesn't make sense to be here. Let's put it here because that's ID value, and let's create the same for the output counter. ID value out count value. Let's do good old loop here. So int 64t Okay, now we have index here, and we also need mapping and out count index. Yep. Okay. Count value unable to out count value out count value deleter out count value. Yeah, it's definitely super out count value. Okay. Good. We have ID, we have out count, and now we just have to insert record is created. ID inserted. If not ID inserted, then something. and the same out count value. Out count value inserted, then I have a strange behavior here. Mapping. Here is the, oh no, no, it's fine. La 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 la. Out count value. Make int out count index. That's fine. Memory. No pointer. That's fine. That's fine. That's fine. MAGE is not CPP. Have I removed? Okay, okay, okay. Bum, bum. This is super strange. So how to? I've missed some parentheses and now I can't see where is missing. This is fine. This is fine. This is fine. This is fine. For loop. Here. No. Here. Inserted. Inserted. Okay. Okay, let's ignore this warning for now. It should work now. Let's. No. Again, the same problem. So instead of ID, I have ID and out count, which is also integer, which is fine. So if I rerun this, that should be it. If I load module, that's good. I have this. If I run, oops. For some reason the module does not get reloaded. Yeah. If I now create a graph and then run the PageRank module here, out count is 0, which is wrong. So I have 1013 and that's correct, but out count should be, so I have these two, I should have 1 and 1 for the first two, but that's not the case. And why is that the case? Iterator next. Vertex, if vertex. Let me just replace this with this example here. Maybe I need to fetch. Yeah, I'll just do this but with edges. Out edges. If edge is there, just iterator edge, and then no. This is now, I really don't understand why Clang format is that broken. Let's not even try to reload this time. So yeah, I'll try to run this and then history, and then if I run PageRank, yeah, this is now correct. So I now have counts of all outcoming edges. But okay, yeah, it's already 2 hours. 2 hours. Yeah, times go super quickly on these live streams. So I think I'm gonna stop here because we still have a lot to do, and this is going to take too much. I'll continue next Saturday. Yeah, I haven't seen any questions. Yeah, sorry, this was a bit slow and error, full of errors. So yeah, next time I think I'm gonna be much faster with everything, because we managed to set up everything. Plus I have that problem with reloading. That should reload, and I'm not sure. I'll try to debug that and figure out what is going on. Yeah, so yeah, next time I think we're gonna continue from this point, and yeah, please, if you have any questions or suggestions or anything like that, just comment. But yeah, that's more or less it for today. I hope you learned some stuff, and yeah, Thanks for watching again, and I'll continue next Saturday with the PageRank stuff. Thanks and bye bye.